Hi, I'm Dr. Evan Matthews. I'm here to talk to you about different methods of doing body fat composition testing. All right, so there's a lot of them out there. I'm not going to cover all of them, but I'm going to cover some of the most common ones and talk about sort of the qualities of them and some of the not so great things about them. So they all have pros and cons. All right, so let's look at this list here. So I have stars next to the ones that I deem as a gold standard, or at least were once considered a gold standard, and then I have 2 stars next to the one that's mostly considered the gold standard today. All right, so one thing that's not on this list that is also a gold standard today is MRI testing, but that's not nearly as common as the other ones on this list just because it's a much more expensive machine. All right, so the first one on the list is dual energy X-ray absorptiometry, or DEXA, and we'll talk about each of these in detail on future slides. So we'll go right down the list here. The second one is hydrostatic or underwater weighing. So that's measuring somebody underneath the water. The third one is air displacement plethysmography. Most of the time you're going to hear this just called BodPod, because at least to my knowledge it's the only system that's available for doing this. So all of these are very high quality measurements that can be done as long as they're done correctly. They can give you a very, very accurate gold standard quality measurements. All right, so these 2 down here, though, even though they're not quite gold standard quality, they're still pretty good, and they're much easier, faster, cheaper, and so these are the ones that are going to be done most of the time in fitness centers. All right, so the first one is skin fold thickness, so that's measuring, pinching the skin and measuring the different thicknesses. The next one is bioelectrical impedance analysis, so BIA is the abbreviation usually people say, and that uses electricity to assess body fat percentage. All right, so of these, the hydrostatic weighing, the air displacement plethysmography, and the skin fold thickness measurement types are all going to calculate body density first, and then from body density you put it into an equation like this Siri equation that's a pretty common one in order to calculate body fat percentage. So a lot of these are a little bit on the math heavy side. All right, so let's go ahead and get into this, go one at a time and talk about some of the pros and cons. All right, so the pros of DEXAs is that it can quantify both the soft tissue, like the body fat, which is what we're talking about, and it can also look at bone density. So this is actually what it was designed for, is to look at bone density. So most of the time, if somebody's getting a DEXA scan in like a hospital setting, it's in order to look at their bone density and see if they have osteoporosis or something like that. But it's a very precise, very reliable measurement. Again, it's a gold standard, the current gold standard measurement that you're going to see in most research papers. Some cons to it is it is fairly expensive. A very cheap version of DEXA, you're looking at probably around $40,000, maybe a little less than that for some models, but they can go up to well over $100,000 for a DEXA machine. So they're very, very expensive. The next sort of con here is it does give a very low dose of radiation. So it is a very, very small amount of radiation, but because it gives radiation, a lot of states regulate it very tight. So I live in New Jersey at the moment. So in New Jersey, it's very, very difficult to use a DEXA machine. Other states, so if I went over to Pennsylvania, which is where this machine is, over at the University of Scranton, it's much more lax, and I could go there and learn how to use it in probably 20 minutes and then run a DEXA scan on somebody, and that's completely legal. Again, New Jersey and some other states, that's not how it is, and there's all kinds of hoops you have to jump through. So, and that's all because of the radiation. But again, it's a very small amount of radiation. I don't know the exact quantities of it, but when I've talked to people who work for these companies and sell these equipment, they'll tell you it's like eating a handful of bananas, 4 or 5 bananas in one sitting, because bananas have potassium, which is radioactive. But so it does have radiation, but it's an extremely small dose. So unless you're doing it several times a day on yourself, you're probably going to be just fine. But because of that, again, it can be heavily regulated depending on your state. All right, so those are the main cons to it. Again, gold standard, so if you have access to it and your state allows you to use it, it's definitely probably your best bet. All right, so the next one is hydrostatic weighing, also known as underwater weighing, because you actually go under the water and you weigh yourself. All right, so this is one of those densitometry measurements I mentioned. So you're actually going to calculate body density, and then from body density, you're going to calculate body fat percentage. All right, so with this, it operates under the assumption that your solid tissues that are not fat are going to sink in the water, and fat is going to float in the water. So it makes you more buoyant. So you're displacing water, increasing your buoyancy. So if you weigh yourself on dry land and then you weigh yourself in the water, you're going to be much, much lighter in the water, and that's because your body fat floats. One thing to keep in mind is one of the limitations of this is that air also floats. So the air that's trapped in your digestive tract or the air that's trapped in your lungs, it will also cause you to float and lower your body weight under the water. So you need to account for that in some way, at least the air trapped in your lungs. It's the other air. There's not much you can do to account for that. Doing some sort of spirometry measurements can be helpful in order to either calculate or estimate residual volume, which is the air left in your lungs after you've blown out all of your air. Because the reason why you want residual volume is basically you dunk your entire body under the water, you blow out all of your air until there's nothing left, and then you hold your breath, and that's when they do the measurement. So it can cause some anxiety in some folks. It does require you to get fully wet. You have to be wearing some sort of bathing suit type clothing or something else that can get wet and not hold air, and that's not very heavy. So it, for some people, isn't the right choice. It can cause a lot of anxiety in a lot of people, but it is a pretty good measurement as long as you follow a lot of guidelines in how you do the testing and the person's very still under the water and they blow out all their air. Again, this is an old gold standard. For several decades, this was the gold standard that everything was compared to, but for nowadays, it's not quite as good as what some of the newer technologies like DEXAs can do. All right, so the next one here is air displacement plethysmography. You can see a picture of the BodPod and somebody in it right here. Again, the BodPod is, to my knowledge, the only commercial version of this that is available, and it works somewhat similar to the underwater weighing. When you do the underwater weighing, you're displacing water and then using the weight of the individual to determine their body density. Here, you're displacing air and you're also weighing the person on a scale, and from that you can, with some of the fancy math that it's doing and the proprietary calculations, calculate body density from that, and then it automatically calculates body fat from that in the software of the machine. So this is a fairly expensive device. You're looking at probably around $50,000 or more to buy a new BodPod. So it is quite pricey to get it, which is the reason why a lot of fitness centers do not have it, even though it's fairly easy to operate. It's basically, as long as nobody's moving around the machine, either inside or outside the machine, it's going to give you pretty good numbers. Notice that he is wearing a swim cap to compress his hair. He's not wearing a shirt. If he had a lot of chest hair, we'd have to shave his chest. So you don't want to have any trapped air against your body. So typically you want to wear skin-tight minimal clothing in the BodPod, because what it's going to do is it's going to cause a pressure shift, and it's going to use that pressure shift to estimate the air that you're not displacing inside the capsule here, the BodPod. And so if there's any air trapped between your clothing and your body, the air heats up and then it becomes easier to compress, and it actually makes you look like you are a little bit lighter than you actually are. So not lighter, but less body fat than you actually are. So it's not the best technique for somebody who's bigger, who either might feel uncomfortable wearing this kind of clothing or who just might not fit into the BodPod. But it is a fairly large device and most people will fit into it. Like the underwater weighing, some people do get a little bit of anxiety. You're putting somebody in a very small closed-in space. The window helps, and there's also a little emergency button underneath. The person starts to panic, they can hit that and it'll open the door. The main con to this, though, is is the price. All right, again, it's a very expensive, $50,000 plus. So that is the main reason why you're not going to see a lot of these out there, but they do give pretty accurate, good measurements. All right, so on to the non-gold standard measurements here. These are more like your field measurements for the most part. These are what you're going to see in a lot of fitness centers. All right, the skin folds, the first one here, you go around the body, you pinch the skin, then you use this caliper here, and there's different types of calipers out there, and you measure how thick the skin and the underlying fat underneath that skin is, and then you do that to several locations, and the locations vary depending on which formula you use. Usually you're looking at a 3, a 5, or a 7 site formula. The 7 site formula is my personal choice just because it encompasses more sites. So if somebody carries their weight in a little different locations, you're probably going to hit those locations. So you're going to get a fairly accurate measurement. The measurement error to this is about 3 to 3.5%. So that's the standard error of the estimate. So basically what that means is if you have a measurement of 10% body fat by skin folds, you're really somewhere between about 6.5% and 13.5%. And so you have a 68% chance of being somewhere in that range. So it's all based on the normal distribution and statistics and things we're not going to go into here. So it is fairly accurate. All of these have some error to them, so that's not a ton of error, but it is some error that you need to keep in mind. So the pros is it can be done pretty much anywhere. The equipment is more expensive than you would think based on how small this device is and how low tech it is, but it's expensive for the type of technology it is. A caliper like this is probably going to run you somewhere around $200-300, something like that. But again, $200 to $300 in a fitness center that has a pretty decent set of funds set aside for this kind of stuff. That's not a ton of money, and it can be used for a really long time. It's reusable. It's not going to be used up, and it's accurate for most people in most situations if the technician or the fitness expert who's doing it is very good at it. And that's where the real problem lies with this, is most people who haven't done it a lot or haven't been heavily critiqued in their technique are not very good at this. You'll see that most people, when they do skin folds for the first several times, get numbers that are completely off the wall, that are definitely not accurate. It takes a lot of precision of your pinch in order to get it to be accurate. All right, so let's move on then to the bioelectrical impedance analysis, or BIA. So this can be in several different model types. What's being depicted here is a foot-to-foot version. So the electricity goes into one leg and goes through the lower torso and comes down the other leg, and then the machine calculates the impedance to that electricity. So in other words, how much resistance your body gives to the forward movement of that electrical current. And the more fat you have, the more impedance you're going to have, so the greater resistance you will have to that electrical current. And so basically the idea here is that body fat has very little water in it, which means it's not going to conduct electricity very well. Your lean tissues like muscle and organs have a lot of water in them, and so they conduct electricity really well, and they don't resist that electricity very much. So the more body fat you have, the more resistance you're going to give to the electrical signal that's going through you. Again, this is a foot-to-foot one being shown here, but they also make them where it goes from hand to hand, or you can have ones where they're segmental systems, which means you have a hand-to-hand and a foot-to-foot all together, and it does it in all the different patterns are tested in order to estimate body fat of your torso, of your right arm, your left leg. So you can get a lot of area-specific body fats out of that that model of bioelectrical impedance. So it's a super easy machine to use. You basically step on, plug in some biographical information, your height, your weight. If it doesn't have a scale, you put in your weight. If not, it measures it itself. Your sex, if you're an athlete, if you're not an athlete. And from that, it can estimate body fat percentage within about a 2.5 or 2.7 to 6.3% error, depending on the device and the study that the research study that you look at as far as the accuracy. But really quick, really easy. Some of the machines can be expensive. You're looking at the high end, somewhere around probably $12,000, $13,000. The low end, you can probably get these things for $40 or $50 at like a Walmart, but you get the quality that you pay for. So if you're going to buy one of those really cheap ones, they're not going to be nearly as accurate as the more expensive ones. But you can get a fairly decent one for probably around $1,500 to $2,000. So a little pricey, but again, within the budget of most fitness centers. The real issue with these machines isn't so much the cost, it is all the assumptions that they make. All right, so again, it uses resistance of your body in order to estimate body fat percentage, which means you have to have the right hydration status for the machine to get a decent estimate. So if you exercised in the last several hours, if you ate in the last several hours, if you drank too much or too little in the last several hours, all those things are going to throw off the machine and give you sometimes really crazy estimates. So if you were to, let's say you're 10% body fat and you go and you do a lot of exercise and you dehydrate your body, you're going to then jump on the scale, which is what a lot of people do. They go to a fitness center, they exercise, and they jump on the scale, the BIA scale, at the end of their workout. It's going to tell them they have like 30% body fat. So, 20% above what they actually have. And that's because they messed with their hydration beforehand. So again, these scales are really quick, really easy to use. As long as they follow the pre-testing guidelines, they're reasonably accurate, but there's a lot of pre-testing guidelines, more than what I even described here. So if you're going to use one of these pieces of equipment, you need to make sure you read what the manufacturers tell you to follow, because that's what they used in order to test the validity of their equipment. So make sure that you follow all those when you're going to test people using bioelectrical impedance. All right, so those are all the techniques. Let's just talk a minute here about body composition and specifically body fat percentage and where you kind of want to be with that and all that kind of stuff. All right, so when it comes to sports, so fat-free mass, so everything but the body fat, you're talking muscles, organs, bones, those sorts of things. Those are usually the things that you want, right? You want good, strong, large muscles for most sports. You want strong bones. Obviously, you don't want to do, atrophy your organs in any way just for health reasons. So fat-free mass is usually a good thing. It helps with power sports, strength sports, endurance sports. So those are all that's the part of body composition that you want typically to be pretty high. Some endurance sports where you're carrying your body weight over a long distance, like a distance runner, a cyclist, something like that, having a lot of muscle mass isn't necessarily a good thing because you're just carrying more mass and it makes it harder to do the sport. But in general, more muscle is a good thing. On the other side of things, more body fat is usually not a good thing for sports. Again, I'm not telling you to go super low here, but usually the lower your body fat, the better for your athletics. All right, so carrying a lot of extra fat, all right, so not normal fat, but more fat than what you need for health, is going to give you more energy storage, which to some degree is a good thing, but it's generally thought of as a negative thing for sports because it's a lot of extra weight that is unnecessary. All right, so the more weight you're carrying that isn't going to be sort of functional, like muscle, where it's going to allow you to move and to produce force, that's just going to decrease your athletic performance. All right, so most athletes, so males, are usually somewhere between 5 and 15% body fat. 5 being pretty low. You probably don't want to be quite that low, but a lot of male athletes are. Women usually between 10 and 18% body fat, so a little bit higher than the men. And for some women, that's going to cause some issues, that things like amenorrhea and injuries and health issues. But same thing with the males. If you're too low for too long, you can get some issues as well. A lot of problems with bone health. but we won't go into that in this video. All right, so weight class sports oftentimes are going to cause people to lose a lot of weights in order to hit a certain class. Aesthetic sports, your gymnasts, your cheerleaders, your fitness and bodybuilding competitors, those people are oftentimes going to be very, very lean. Also, endurance athletes tend to be very, very lean because of what I mentioned before, where they don't want to carry a lot of extra mass around. All right, so your strength, your power athletes tend to be on the higher end, typically a little higher than what's being shown here, because body fat is not necessarily such a negative thing for most of those athletes. All right, so the super high body fat athletes are going to be your sumo wrestlers, your heavyweight powerlifters, heavyweight wrestlers, your football linemen. Those are the people who are going to typically have a lot of body fat and who are usually at the high end, if not well above these ranges here. I have to mention this when talking about this just to make sure that people don't go too crazy, because again, usually lower body fat is a good thing for both athletics and for health, but within the normal range. You don't want to go super low, and even these values here are pretty low. Some of those, the 5 is pretty low, the 10 is pretty low for women. All right, so if you go too low, if you say develop like an eating disorder, which is fairly common, especially in these sports here, the weight class sports, the aesthetic sports, the endurance athletes, eating disorders can cause all kinds of health issues as well as decrements to your sports performance eventually. So you want to make sure you're maintaining a healthy weight and you're not getting too lean where you start sacrificing health for your athletic pursuits. All right, so that was a real quick overview on how to do body composition and sort of what the good ranges are for athletics. And that was a really quick overview of the good ranges for athletics. That conversation really needs to be quite a bit longer if you're going to start to try to change your body fat percentage or change the body fat percentage of athletes that you work with. So you'll need to do a little more research for that. But if you have any questions, please put those in the comment section below and I'll try to get back to you. Otherwise, please come back and watch another video. Thanks.